Hi, I'm Mark Barsamian. In the previous two videos, we discussed consumer's surplus and producer's surplus. In those videos, we were given either a demand price function or a supply price function, and we were given a price point denoted P bar, and we used that information to compute either consumer's surplus or producer's surplus. In this video, I'll discuss the idea that for a particular item that has a given demand price function and given supply price function, those two functions together will determine the price at which the item will sell. That price is called the equilibrium price. This material is from section 6.2 of the book, more specifically the middle of page 406 to the middle of page 407, example 7. The corresponding homework is this set of 3 exercises, 2 from the Barnett book, although only one of them is in the MyLab system, and this one exercise from another book that is in the MyLab system as well. Recall the concept of quantity demanded and the demand price from the video for homework 88. The quantity demanded, denoted by either X or Q, is a variable that represents the number of items that consumers are willing to buy. The demand price, denoted by the variable small p, is a variable that represents the selling price that's necessary for consumers to be willing to buy the quantity X or the quantity Q. The value of the variable p is given by a function denoted capital D of X or capital D of Q. That function is called the demand price function. The graph of the demand price function is called the demand price curve. And recall that when the selling price for an item is high, consumers will not be willing to buy many of the items. But when the selling price is low, consumers will be willing to buy a lot of the item. Therefore, the demand price curve will go down as one moves from left to right on the graph. That is, the demand price function will be a decreasing function. So in this graph, we have the quantity demanded on the horizontal axis, and on the vertical axis, we have the demand price. And recall the definition of consumer surplus. The consumer surplus for the demand price function capital D of X at the price point X bar comma P bar. It means this definite integral, and in terms of the graph, that means the area of this simple region. That's the region bounded by the demand price curve and the horizontal line P equals P bar, and the vertical line X equals 0, and ending at this point X equals X bar. And recall the concept of quantity supplied and the supply price from the video for homework 89. What I call the quantity supplied, denoted by either X or Q, is a variable that represents the number of items that producers are willing to supply. And what I call the supply price, denoted by small letter p, is a variable that represents the selling price that's necessary for producers to be willing to supply the quantity X or Q. And the value of that variable p is given by a function denoted capital S of X or capital S of Q. It's called the supply price function. And the graph of that function is called the supply price curve. In this diagram, we have a picture of what could be a supply price curve. Recall that when the selling price for an item is low, producers of the item will not be willing to supply many of the items. So that is this part of the graph. But when the selling price is high, producers will be willing to supply a lot of the item. So that's the behavior over here. So the supply price curve will go up as you move from left to right. That is, the supply price function will be an increasing function. And recall the definition of producer's surplus. The producer's surplus for the supply price function capital S of x at the price point x bar p bar is defined to be the value of this definite integral. In terms of the graph, it's the value of the area of this simple region. That simple region is bounded on the top by the straight line p equals p bar, bounded on the bottom by the supply price curve, bounded on the left by the vertical line x equals 0, and bounded on the right by the line x equals x bar. This point on the graph is the point x bar comma p bar. Now I want to talk about equilibrium price and quantity. In the videos for the homeworks 88 and 89, we studied examples in which consumer surplus or producer surplus was calculated for a given price level, p bar. In an actual competitive market, though, the price level for a particular item will be the price at which the quantity that producers are willing to supply equals the quantity that consumers are willing to buy. Observe that since the demand price curve goes down as you move from left to right, and the supply price curve goes up as you move from left to right, if the two curves cross, they'll cross at exactly one point. This point is called the equilibrium price point. The official definition follows on the next page. So here's the definition of equilibrium quantity, equilibrium price, and equilibrium, this should say equilibrium price point. For a given supply price function, P equals capital S of x, and given demand price function, P equals D of x, what's called the equilibrium quantity, denoted x bar, and equilibrium price, denoted p bar, are defined to be the quantity and price such that this equation is true. That is, these coordinates, x bar comma p bar, are the coordinates of this point where the demand price curve and the supply price curve cross. For the rest of this video, I'll do two examples of computing the equilibrium price point for a given supply price function and demand price function, and then computing consumer surplus and producer surplus at that equilibrium price point. Example 1 is similar to 6.2 number 77. Suppose that the demand price function is this function, d of x equals 200 minus 0.02x, and the supply price function is this function, s of x equals 0.01x plus 50. Question A is to find the equilibrium price point. Well, we have to set d of x equal to s of x and solve for x. So there's my d of x and my s of x set equal to each other. We solve for x, and the result is x equals 5,000. We substitute this into the formula for d of x to find p. So there's the formula for d of x. When I substitute in x equals 5,000, I find that the value of p is 100. We should check this result by also substituting the same value of x into the formula for the supply price function. Well, there's the formula for the supply price function. When we substitute in x equals 5,000, we end up with p equals 100 again. So those results agree. So we conclude that the equilibrium price point is x bar p bar equals 5,000, 100. Question B, find the consumer surplus at the equilibrium price point. Well, remember that the consumer surplus is given by this integral calculation. So we substitute in our value for x bar, is 5,000. We substitute in our value for p bar, that's 100. And then we substitute in the formula for the demand price function, that formula. And then we get to work. First thing we do is we simplify the integrand before integrating. Then we do the usual stuff. We use the fundamental theorem of calculus to tell us that we can replace this definite integral with this calculation involving an indefinite integral. The indefinite integral result has a constant of integration, which gets canceled in the first subtraction step, and the rest is just careful arithmetic involving substituting in these x values, x equals 0, x equals 5,000, and being very careful about the arithmetic. And the result is that the consumer surplus is $250,000. Question C, find the producer's surplus at the equilibrium price point. Well, the producer's surplus is given by this integral formula, so we have to substitute in our value of x bar, which is 5,000, substitute in our value of p bar, which is 100, substitute in the formula for the supply price function, that formula, and we end up with this definite integral to do. First thing we do, again, is to simplify the integrand before integrating. Then we have the same kinds of steps that we have in all of these problems. We have the step where we use the fundamental theorem of calculus to replace the definite integral with a calculation involving an indefinite integral. The result of the indefinite integral comes in here with its constant of integration. The constant of integration gets canceled in the first subtraction step. The rest of the careful arithmetic goes on, and we end up with a value of 125,000 for producer's surplus. Question C, illustrate the results of A, B, and C with a graph. Well, in question A, we found the equilibrium price point. That was this point that has coordinates 5,000, 100. So there are the results of question A illustrated on the graph. Now in question B, we found the consumer surplus was $250,000. That's the area of this green region. Now remember what that means. That number is the amount of money that consumers will feel like they saved if the selling price is $100. Now, why would consumers feel like they saved anything? Well, it's because there are a bunch of consumers who would have been willing to pay more than $100 for the item. So if they're able to buy the item for $100, this green region represents the amount of money that they'll feel like they saved. In question C, we found that the producer's surplus was $125,000. Remember what that means. That's the amount of money that producers will feel like they made extra if the selling price is $100. Now, why would they feel like they made extra money? Well, because there are a lot of producers who would have been willing to sell the item for less than $100. So if the item is selling for $100 and they were able to sell it for that much money, they'll feel like they made a bunch of extra money, and that will correspond to the area of that red region on the graph. So there are the illustrations of A, B, and C on a graph. Quick remark. Observe that we could have found the consumer's surplus and producer's surplus using geometry. These regions are triangles. The base for both these triangles is 5,000. The green triangle has a height of 100. The red triangle has a height of 50. If we use those numbers in the formula for the triangle area, there's our base of 5,000. For the green triangle, there's our height of 100. For the red triangle, there's our height of 50. We end up with those numbers: $250,000 for the consumer's surplus and $125,000 for the producer's surplus. Let's go on. Example 2. This problem is similar to a problem that's in the Barnett book but not in the MyLab system. It's also similar to a problem in a book by Lyle. This problem actually is in the MyLab system. Suppose that the demand price function is this quadratic polynomial. Notice that the variable is q, not x, q for quantity. And suppose that the supply price function is this quadratic polynomial. Question A is to find the equilibrium price point. Well, as before, we set the supply function equal to the demand function, and we solve for Q. So there's the supply function, and there's the demand function. When we solve for Q, we reach this point where we have a quadratic polynomial equal to 0. We can solve this using the quadratic formula, using the following coefficients. A is the number 2, the coefficient of the Q squared term. B is the number 8, that's the coefficient of the Q term. And C is the number minus 1050, that's the constant term. I'll do that solution on the next page. So using the quadratic formula and then plugging in those values for A, B, and C, we get this. This all simplifies to this expression, minus 8 plus or minus 92 over 4. Now we're only interested in positive Q values because Q represents quantity of an item bought and sold. So it's got to be a positive number. So we are going to choose the plus option. So the final answer is that Q has to be the number 21. We substitute that Q into the formula for the demand price to find the price. So when we do that, there's the demand price function. We substitute in the number 21, and we end up with the price of 513. Now we should check this result by also substituting the same value of Q into the formula for the supply price. So there's the supply price function. We substitute in that value of Q of 21, and we end up with the number 513. Those results agree, so we conclude that the equilibrium price point is Q bar comma P bar equals 21 comma 513. Question B, find the consumer surplus at the equilibrium price point. Well, there's our formula for consumer surplus. We substitute in the value Q bar equals 21. Again, remember that previously we used the symbol X bar for that, the equilibrium quantity. We substitute in the formula for the demand price. That's this quadratic function. We substitute in the number for the equilibrium price, the P bar, that's 513. And that leaves us with this integral to do. As always, we simplify the integrand, and then we do the usual stuff. The step involving using the fundamental theorem of calculus, the step where we do the indefinite integral and put the results there along with the constant of integration. We substitute in Q equals 21 to get this expression. We substitute in Q equals 0 to get this expression, and we subtract. The constant of integration cancels, and then we just do careful arithmetic, and we end up with the result 74.97. Question C, find the producer's surplus at the equilibrium price point. Well, producer's surplus is given by this integral formula. We substitute in our value of the equilibrium quantity. Q bar is 21. We substitute in the value for the equilibrium price. P bar is 513. We substitute in the formula for the supply price function. That's this quadratic function. We end up with this definite integral. We do all the usual steps, and we end up with this answer. The producer's surplus is 66.15. Question D, illustrate the results of A, B, C with a graph. Well, first thing, we should label the axes. So there I've labeled the axes, and I've illustrated the results of question A. The equilibrium price point has coordinates 21, 513, and it's denoted by this symbol Q bar, P bar. And then we see the green shaded region corresponds to the consumer surplus. That's the area of the region bounded by the demand price curve and the horizontal line P equals P bar, and bounded on the left by the vertical line Q equals 0. And with the right endpoint there at the equilibrium price point, the Q coordinate of that is Q bar equals 21. And remember what that quantity means. The consumer's surplus is the amount of money that consumers will feel like they saved if the selling price is $513. That's the result of question B illustrated. Question C, we found that the producer's surplus was 6615. That region is bounded above by the horizontal line with equation P equals 513, bounded below by the supply price curve, bounded on the left by this vertical line with equation Q equals 0, and bounded on the right by Q equals Q bar equals 21. And remember what the producer's surplus represents. That represents the amount of money that producers will feel like they saved if the selling price is $513. All of these producers who would have been willing to sell at a lower price will sell if the selling price is $513. And a lot of them will feel like they've made extra money because they would have been willing to sell at a lower price. That's the end of the example, and that's the end of the video. Thank you.